To the session. So my name is Vibhati, and in today's session we are going to discuss few more amazing questions. So this is your NEET 10 a game changer series, and we have complete 10-day series for you, and this is day number 5. So in today's session I am going to discuss few questions which are more appropriate for section B in your NEET exam. Alright. So let's start with the session, but before starting the session guys, this is the timetable. 12 to 1 I'll be taking your class physics by me Vibhati. 1:30 to 2:30 we'll be having zoology class with Tanya ma'am, then 3 to 4 botany class with Beena ma'am, and 4:30 to 5:30 we have chemistry class with Pawan Kasu sir. You can watch live this session. For that you have to subscribe to the channel and press the bell icon to get the notifications for all the sessions over here. Hello everyone, hello Bacho. Alright, so let's start with question number 1. A regular hexagon of side 10 centimeter has a charge of 5 nanocoulomb at each of its vertices. The electric potential at the center of the hexagon is. So we have regular hexagon like this, and at each corner we have a 5 nanocoulomb. Like this, and we have to find the electric potential due to this charges at the center of the hexagon. Good afternoon beta, good afternoon everyone. Alright, please start solving the questions. Come on guys. So the center is equidistant from all the corners of this hexagon, and it is equal to the side of the hexagon, right? The distance of the center from the corner is same as that of the side over here. So potential due to a point charge at a distance r is kq divided by a, and we have how many charges? 6 charges. So potential due to all these 6 charges will be 6 times kq divided by a. So k is 9 into 10 to the power 9, q is 5 nanocoulomb into 6 divided by a. A is 0.1 meter, right? Hello beta, it is 0.1 meter, so it will be 30 into 9 into 10. This point will go up, so it will be 10. This point will remove point, 10 will be up. So this is 270 into 10 volt, which is 2.7 kilovolt. So correct answer is option B. Correct answer is option B. Right? Hello Vicky, hello Meghna, hello Siddhabati, Prem Kumar, Vanama, Vandana, Bhargav. Option B is the correct answer. Hello Rakshit. Okay. Alright. Let's start with the next question over here. Two coherent waves of intensities in the ratio 9:4. I1 upon I2 is 9/4. So you can write I1 as 9x and I2 as 4x. Let's say x is the common ratio. Undergo interference. The ratio of maximum and minimum intensities in the interference pattern is, you have to find the ratio of I max to I minimum. Okay, so I max divided by I minimum. This is what we have to find. What is I max? It is under root of I1 plus under root of I2 whole square divided by I minimum is under root of I1 minus under root of I2 whole square. This is important for us. Please remember this expression for I max and I minimum. Alright, try this one everyone. Try this one bacho. Under root of I1 will be under root of 9x plus I2 will be 4x whole square divided by under root of 9x minus under root of 4x whole square. So this will be 3 root x minus plus 2 root x whole square divided by 3 root x minus 2 root x whole square. So it will be 5 root x whole square divided by root x whole square. Cancel, cancel. So it will be 25:1. It will be 25:1. So correct answer is option B. Okay, under root of I1 plus under root of I2 whole square divided by under root of I1 minus under root of I2 whole square. Well done beta, good job everyone, good job. Alright, next is this one. In a meter bridge, the null point is found at 40 centimeter. When an identical resistance is connected in parallel to the smaller one, the balance point shifts by. You have to find if you connect identical resistance in parallel with the smaller resistance, the balance point will shift by what amount. So let's say this is R, this is S, and this is the meter bridge wire over here, and this is your initial balancing point P, this is A, B. So this is 40 centimeter, this complete length is 100 centimeter, AB wire, so PB will be 60 centimeter. So it is nothing but the balanced Wheatstone bridge, right? It is nothing but the balanced Wheatstone bridge. So ratio of R to S is what? Length of AP wire divided by length of PB wire. So R upon S is length of AP is 40 centimeter, PB is 60 centimeter, so it is 2 by 3. R upon S is 2 by 3. That means if R is 2x, then S is 3x. So out of this two, which one is smaller? R is smaller, right? Out of R and S, R is smaller. So now what we are doing is, we are connecting one identical resistance in parallel with the smaller, that is R. So this is the new setup. R and R parallel, this is S and this is your AB wire. So new balancing length is, let's say, somewhere over here. This is P. Alright. Now the combination of these two parallel will be R by 2, right? Combination of this two parallel of R is R by 2. So now we have R by 2S and it is balanced by, let's say, AP length is L. So remaining PB length will be 100 minus L. So we have balancing condition as R by 2 divided by S is equal to L upon 100 minus L. So in this one we have 1 by 2 times R by S is equal to L upon 100 minus L. But R by S is equal to 2 by 3. Put it here. So you will be getting 1 by 2 times 2 by 3 is equal to L upon 100 minus L. 2 cancel. So what do we have? We have 1 by 3 is equal to L upon 100 minus L. So 100 minus L is equal to 3L. So 4L is equal to 100 and L is equal to 25 centimeter. Earlier the balancing length was 40. Now we have new balancing length as 25 centimeter. So how much it is shifting? 40 minus 25, that is 15 centimeter, which is option A. Option A is the correct answer. They are asking the shift beta. They are not asking the new balancing length. If they ask new balancing length, then option D is correct. But if they are asking shift, that means earlier it was 40, now we have 25. So 40 minus 25, how much is shift over here? 15 centimeter. Well done guys, good job everyone. Alright, let's move on to the next one. Match the following. Set 1 you have to match with set 2. Manganine, soft iron, cadmium, GaAs. These are used in what devices over here? Try to match everyone. Now these types of questions are directly from NCERT. Fine, so that is why we say that NCERT is very important for NEET exam. So if you get these types of questions, that means this information has been taken from NCERT only. Chaliye. What should be the correct match over here? Manganine wire is used in meter bridge. So A is matched with R. Then soft iron is used in electromagnet. B is matched with Q. Cadmium is used in nuclear reactors. Okay, as control rods over here. Yes, it is used in nuclear reactors. So C is matched with S. So correct answer is option A. and GaAs is used in infrared LED. So correct answer is option A. Please remember this match. It might help you in your NEET exam. Alright, chaliye, let's move on to the next one. A straight wire of mass 300 gram and length as 1.5 meter carries a current of 2 ampere. Carries a current of 2 ampere. It is suspended in mid-air by uniform transverse magnetic field. The magnitude of the magnetic field is, it is suspended beta. It is suspended mid-air. That means what? That means the net force acting on the wire is 0, right? That means the net force acting on the wire is 0, right? That means whatever magnetic force is acting on the wire, it is balanced by mg. Now it is transverse magnetic field. That means magnetic field is perpendicular to the plane of the wire. That means what? Theta is equal to 90 degree. So magnetic force on current carrying wire is ILB sin theta. So it will be just ILB because sin 90 degree is 1. So ILB should be balanced by mg to keep it suspended in mid-air. I is given as 2, L is given as 1.5. We have to find magnetic field. M is 300 gram, which is 0.3 kilogram, and G is 10. So B will be 3 upon 3, which is equal to 1 Tesla, which is equal to 1 Tesla, right? So this is the correct answer. This is the correct answer. This is from the complete syllabus beta. Complete syllabus, from entire syllabus. Well done, guys. Now next is, when a light ray falls on a transparent slab at 60 degree angle like this, and it is partially reflected from, it is completely polarized. The refractive index of the material is. So if the light is completely polarized over here, then what will happen? What will happen? The angle of incidence should be equal to Brewster angle, right? And in that case, mu is equal to tan of Brewster angle over here. So what is theta? 60 degree. So mu will be tan of 60 degree. Tan of 60 degree is root 3. So over here, refractive index of the material is root 3, which is option A. If the light is completely polarized, reflected light is completely polarized over here, then the angle of incidence should be equal to Brewster angle, and tan of Brewster angle is equal to mu. Please remember this one. This is important for us. This is from wave optics, polarization of light. Alright, let's try this one. Two charges, 3 into 10 power minus 8 coulomb and minus 2 into 10 to the power minus 8 coulomb are separated by 15 centimeter in air. This is the separation between these two charges. The distance of point where electric potential is 0. The distance of the point, the point at which the net electric potential is 0, that we have to find. So let's say that point is somewhere over here at a distance of x from positive charge. So remaining distance from the negative charge will be 15 minus x like this. So net potential at this point P should be 0. So it is K Q divided by R is x plus potential due to negative charge is K into charge is minus 2 into 10 to the power minus 8 divided by 15 minus x, and it should be 0. So you can take K common and cancel it out. 10 power minus 8 common and cancel it out. So what do we have? 3 upon x minus 2 upon 15 minus x is equal to 0. So it will be 3 upon x is equal to 2 upon 15 minus x. Cross multiply. Now cross multiply. Okay. So it will be 45 minus 3x is equal to 16. Oh sorry, this is x, not 8. So this is 2x. So we have 45 is equal to 5x. So x is equal to 9 centimeter. So the point is at a distance of 9 centimeter from the positive charge, and it is in between the charges. So correct answer is option B. Okay. That is for electric field beta. The null point will come over here closer to the smaller charge. That is for electric field and electric force because they are vector quantities. Here there is nothing like that. Okay. Yeah. Next is this one. A short bar magnet is placed in a uniform magnetic field if the work done to turn the magnet from the direction of field to the normal to the field is W. Initially, the magnetic dipole moment and the magnetic field are parallel. Now we are turning this bar magnet such that its magnetic dipole moment is perpendicular to the field. So theta 1 is 0 degree, the angle between M vector and B vector, and theta 2 is 90 degree. So in order to rotate this bar magnet from this orientation to this orientation, work done is W. Then what they are asking is, what is the potential energy of the magnet when it is in stable equilibrium position? When the magnet was parallel to magnetic field, what was the potential energy? So work done in rotating the bar magnet is MB cos theta 1 minus cos theta 2. So it is MB cos theta 1 is 0 minus cos theta 2 is 90. So it will be MB 1 minus 0 which is equal to MB. Now potential energy of the bar magnet is minus MB cos theta. So it will be in stable equilibrium position, theta 1 will be 0 degree. So it will be minus MB cos 0 degree which is 1. Right, so it is minus MB, but work done is MB, so potential energy is minus of W. I am just replacing MB with W. So potential energy will be minus W over here, which is option B. Okay, alright. Chaliye. Let's try this one. A transformer works on which principle? Resonance of LC oscillation, mutual induction, self-induction, or eddy currents? You have to tell me. This is the most simple question, the most simplest question of this session. Yes, it is based on mutual induction. It has two coils, primary coil and secondary coil. With the help of primary coil, we induce EMF and current in the secondary coil, right? That is the working principle of transformer. Let's try this one. When an electron in hydrogen atom is excited from its third to fifth stationary orbit, the change in angular momentum of electron is Planck's constant is given. So what is angular momentum of electron? MVR, and it should be NH upon 2 pi. Okay, quantization condition, MVR should be NH upon 2 pi over here. Alright, yes, try this one, come on guys. When it is in third orbit, N will be 3. When it is in fifth orbit, N will be 5. You have to find the change in angular momentum. Well done, well done. No, it is small calculation. The calculation is easy. Put pi is equal to 22 by 7. Okay, put pi is equal to 22 by 7. That's it. Angular momentum initial is MVR and it should be NH upon 2 pi. So N is 3, H upon 2 pi. Final is N is now 5, so it is 5H upon 2 pi. So what is the change in angular momentum? L final minus L initial, 5H upon 2 pi minus 3H upon 2 pi. So it will be 2H upon 2 pi, HH cancel, so it is H upon pi. H is already given beta. Okay, H is already given. So it is 6.6 into 10 to the power minus 34 divided by pi is 22 by 7. So 7 will go up. Just remove this point. So it will be 3. So 7 into 3 is 21 divided by 10 is 2.1 into 10 power minus 34. So correct answer is option D. Option D is the correct answer. Calculation is easy beta. Calculation is easy. Okay. Chaliye. Try this one. Next is this one. Yeah. Which of the following represent an SHM? Which of the following equations represent SHM out of this 4? Can anyone tell me? SHM में we represent displacement, velocity, acceleration in the form of sine or cos, right? These are sinusoidal functions. So this is sine cube, not possible. This is not possible. This is e to the power something, it is not possible. But if you look at this one, sine omega t minus cos omega t, you just have to multiply and divide by root 2. Now you can take root 2 common. So it is 1 by root 2 sine omega t minus 1 by root 2 cos omega t. Okay. So root 2. Now 1 by root 2 and 1 by root 2. We'll be replacing this 1 by root 2 and 1 by root 2 with sine 45 and cos 45. Okay. So this is sine omega t into 1 by root 2 over here is nothing but cos pi by 4 minus cos omega t, and 1 by root 2 over here can be written as sin pi by 4, because sin pi by 4 as well as cos pi by 4 both are 1 by root 2. So this is sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b. So it is nothing but sin of a minus b. So it is root 2 times sin of a minus b. So yes, we can represent this last function in the terms of sine alone. In the terms of sine alone. So this is the function which represents SHM. Fine. This is the function which represents SHM over here. Another way of verifying this thing is acceleration should be directly proportional to minus x. If you can do this also, then you can prove that this equation is SHM. Fine. So correct answer is option D. Next is this one. A wire, when stretched by a force F, elongation in this wire is x. Now the wire is recasted into another uniform wire of double the length, double the radius, I'm so sorry. If initial radius is r, the final radius is 2r. And it is stretched by the same force F. Then its elongation will be, what is the elongation in the wire? It is x by 16, 16x, 4x. If you are increasing the cross section area, what will happen to the length, everyone? If you are increasing the thickness of the wire, will the length increase or decrease or remain constant? Can you tell me? If you are increasing the thickness of the wire, what will happen to the cross section area, length? (16x), option C. 18x, oh my god, 18x, is there any option as 18x over here? It's not constant. When you see, you have the same volume, right? You have the same volume as before. Using the same volume of the wire, you have to, yes, it decreases. You have to recast the wire. So initial area is pi r square and initial length is L. Now final area is pi times 2r whole square. So it will be 4 pi r square, which is 4 times the initial area. And final length is, let's say, L dash. So we are keeping the volume same. We are keeping the volume same, right? None of you guys are correct, let me tell you. We are keeping the volume same, right? So if you just compare initial volume with final volume, you will get the length. So A initial into length initial is initial volume, and it should be equal to final volume as A final into L final. So A initial is A initial only, L initial is L, A final is 4 times A initial and L final is L dash. A initial cancel, so L dash is equal to L by 4. Dekho, it is very simple, very simple. What you have to do is, if you are increasing the area 4 times, length will decrease by 4 times. If you are increasing the area 10 times, length will decrease by 10 times. Okay. If you are increasing the area 20 times, length will decrease by 20 times. Fine. So, this is the new length. Now, initial elongation in the wire is x. So, Young's modulus is what? FL divided by A delta L. So, elongation will be FL divided by AY. Initially, it is x. FL divided by AY. Now, finally, let's say it is x dash. We are keeping force same, but length is L by 4, area is 4A, and Young's modulus will be same because we are not changing the material. We are not changing the material. Right? Yes. So, over here x dash will be FL divided by 16 times AY. But what is FL divided by AY? It is nothing but x value. So, x dash new elongation is x by 16. It is 1 by 16 times the previous one, which is option B. Okay. So, that is how it can be done. All of you were saying this option and some were saying 18x, which is not even in the option, right? So, please don't make this mistake. If you want, you can remember this one as shortcut. If you are increasing the area x times, length will decrease by x times. Okay? Chaliye. Next is this one. Same gas is filled in 2 vessels of the same volume at the same temperature. If the ratio of the number of molecules N1 is to N2 is 1 is to 4, then RMS velocity of gas molecules in the 2 vessels will be in the ratio of 1 is to 4, and statement B is the ratio of pressure in these 2 vessels will be 1 is to 4. Which of the following statements are correct? Out of A and B, which statements are correct? What is RMS velocity? It is under root of 3 RT divided by M. We are keeping temperature same for both the gases and same gas is filled. That means M is also same for both. So, if T is same, M is same, RMS speed of both of these molecules will be same in the 2 vessels, right? So, statement 1 is false. It is not 1 is to 4, it is 1 is to 1. Right. So, only B is correct. Why B is correct? Because if you look at this equation, PV is equal to N KT. So, over here B is same, K is same, T is same. So, P is directly proportional to N. So, ratio of P1 to P2 will be that of N1 to N2, and N1 to N2 ratio is 1 is to 4. So, pressure ratio will be 1 is to 4. So, only B is correct, which is option B. Okay. Alright. This is from kinetic theory of gases. Next is this one. A stone is projected at an angle theta with the horizontal from the roof of a tall building. Acha, it is projected at an angle theta with the horizontal from the roof of a tall building and it falls on the ground after 3 seconds. Okay. 2 seconds after the projection, it was again at the level of projection. So, it is starting at t is equal to 0, at t is equal to 2 seconds it is here at the same level of projection, and at t is equal to 3 seconds it is on the ground. Then the height of the building is, you have to find the height of the building. Okay. Chaliye, try this one, come on guys, try this one. This is a good question. It is a good question. You have to break this question into 2 parts. If you just look at this much portion, this is like ground to ground projection, right? So, for oblique projection over here, ground to ground projection, what is the time of flight? 2 seconds. From here to here, it is covering this journey in 2 seconds. So, for this ground to ground projection, what is the time of flight? 2u sin theta by g, and it should be 2 seconds. 2 cancel. So basically u sin theta is equal to g. Right, so we have u sin theta component with us, which is equal to 10 because g is mentioned as 10. Fine. Now, if you look at this complete journey over here, then apply this equation. Sy is equal to uyt plus half ay t square. S is equal to ut plus half at square for y direction that you have to apply. So, if this is initial velocity u, then this component is u sin theta, this component is u cos theta. Acceleration due to gravity is ay, which is in the downward direction, so we will be writing it as minus g. Now, the particle is starting from here, it is going up and coming down. So, it was at this level, now it is at this level. So, what is the net vertical displacement of the particle? Minus h, because displacement, overall displacement is in downward direction, right. So, sy is minus h, which is uy is u sin theta is 10 into t, total time is 3 plus half ay is minus 10 into t square is 3 square. So, it will be minus h is equal to 30 minus 5 into 9. So, it will be minus h is equal to 30 minus 45 and h will be 15 meter. So, height of the building is equal to 15 meter, which is option A. Okay, chaliye, well done guys. Let's move on to this one. A force of 5 Newton acts on a 15 kilogram body. We have a 15 kilogram body and 5 Newton force is acting on it. Initially, the body is at rest. The work done by the force during the first second of its motion is. So, during first second, what is the work done by this force? Try this one, come on guys. Find the acceleration, then displacement. Try this one everyone. Temperature is crossing 42, 43 here in Hyderabad. Option D. Alright, acceleration is force upon mass, which is equal to 5 divided by 15, which is 1 by 3 meter per second square. Okay. Now, we have acceleration, we have time, initial velocity. So, can we find displacement? S is equal to ut plus half at square. So, u is 0, time is 1 plus half a is 1 by 3 into t square is 1 square. So, displacement is 1 by 6 meter. Right. So, work done is force into displacement into cos theta. This is the work done by constant force. So, displacement and force are parallel, theta will be 0 degree, cos 0 degree will be 1. So, force into displacement is your work done, which is equal to 5 into 1 by 6. So, 5 by 6 joules is the work done over here, which is option B. Well done guys, option B beta. Chaliye, let's move on to this one. Now, this is completely information based. The number of wires that are used in Searle's experiment for the determination of Young's modulus of elasticity is. How many wires we use for the determination of Young's modulus in Searle's experiment? This is given in NCERT. Come on. How many wires we use? 1, 2, 3, 4. Option C. We use 2 wire. One is the reference wire and yes, one is the reference wire and second wire is the wire of which we are determining Young's modulus of elasticity. So, correct answer is option C. Next is a gas is compressed adiabatically when volume becomes 1 by 8 initial volume, the temperature becomes 4 times the initial temperature. Then what is the degree of freedom of the gas? Initial volume is V, final volume is 1 by 8. Temperature, initial is T, final is 40, right? So for adiabatic process, what is the relation between temperature, hello beta, and volume? It is TV power gamma minus 1 is equal to constant, right? So you can apply this one. T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. So from this one, T1 upon T2 is V2 upon V1 power gamma minus 1. T1 is T, T2 is 40, V2 is V by 8 and V1 is V power gamma minus 1. So 1 by 4 is 1 upon 2 square and 1 by 8 is 1 upon 2 cube power gamma minus 1. Now you just have to compare power because base is same, right? Because base is same, alright. So over here it is 2 to the power minus 2 and here 2 to the power minus 3 times gamma minus 1. It will go up 2 to the power minus 3 times gamma minus 1. Base is same, that means power must be same. So minus 2 should be minus 3 times gamma minus 1. So 2 should be 3 gamma minus 3. So over here 3 gamma is equal to 5. So gamma is 5 by 3. Gamma is 5 by 3 over here. But what is gamma in terms of degree of freedom? So it is 5 by 3 is equal to 1 plus 2 by f, right? So 5 by 3 minus 1 is equal to 2 by f. So it is 2 by 3 is equal to 2 by f. 2 to cancel. So degree of freedom is equal to 3. Degree of freedom is equal to 3. This is a monoatomic gas. This is a monoatomic gas over here, right? Degree of freedom is equal to 3. Alright. So this is the expression of gamma. If you want, you can remember it. 1 plus 2 by f in terms of degree of freedom. Chaliye, let's move on to the next one. When a coil is connected to a DC source of EMF 12 volt, a current of 4 ampere flows through it. Now, if the same coil is connected to 12 volt, 50 hertz AC source, the current is 2.4 ampere. Then what is the self-inductance of the coil in Henry is? What is the self-inductance of the coil in Henry? Try this one, try this one. Initially, I is V by R. So from this one, V upon I is equal to resistance, which is 12 by 4, that is 3 ohms. So we have resistance from the first information. Now in second information, if you are including the coil as well, right? So if you are including the coil, you will be having XL. So total reactance, total impedance will be under root of R square plus XL square. Fine. So in this one, if you find the value of Z, it will be V upon I or V RMS divided by I RMS. So it is 12 upon 2.4, which is equal to 5 ohm. So Z is equal to 5 ohm, resistance is equal to 3 ohm. So if you put Z and resistance in this equation, you will get XL, right? So Z is 5 is equal to under root of 3 square plus XL square. So from this one, you will get XL as 25 minus 9 square root, which is equal to 4 ohms. So this is XL. But what is XL? It is 2 pi FL and it should be 4. So L will be 4 upon 2 pi f. Frequency over here is given as 50 hertz. So it is 2 upon pi into 50, which is 1 upon 25 pi, which is 1 upon 25 pi, which is option C. Yes, it is nothing but the option C. Okay. Next is this one. It is from logic gates. In the logic circuit shown in the figure, if input A and B are 0 and 1 respectively, the output Y would be. So this is your NOR gate, this is your NAND gate, this is your AND gate. What is the logical operation of NOR, NAND and AND? That you have to remember first. Then only you can solve this question, right? So for AND, NAND and NOR. Try to find it. Input A is 0 and B is 1, and these are your NOT gate. These are your NOT gates. Okay, chaliye, try to find it everyone. Zero, well done, well done. 0, option B, well done. For AND gate, for NOR gate, it will be input 1 plus input B whole bar. For NAND it is A into B whole bar, and for AND it is AB only. So see, this A is going into this NOR gate as 0, and this over here, this B is passing through this NOT, it will become 0. Then it is again passing through this NOT, so it will become again 1. So 0 and 1 are the inputs of this NOR gate. So it will be 0 plus 1 whole bar, which is 1 bar, which is again 0. So output of this NOR gate is 0. Okay? Now for this AND gate over here, the input A is passing through NOT. So 0 is passing through NOT, so it will become 1. So 1 is the first input, 1 is passing through this NOT, so it will become 0. So it is 1 into 0 whole bar, which is 0 bar, which is equal to 1. Now this 0 and 1 both are passing through this AND gate. So final output Y will be 0 into 1, which is equal to 0. So correct answer is option B. Option B is the correct answer. Well done guys, good job everyone, good job. Alright, chaliye. Next is this one. A nucleus of mass number 152 at rest splits into nuclei of mass 27 and 125 respectively. The ratio of radii of these two daughter nuclei is, so radius is directly proportional to a to the power 1 by 3. Apply this concept to find the ratio of radii of these two daughter nuclei. Try this one, try this one. Try this one everyone. Okay. So basically you can write R1 upon R2 as A1 upon A2 to the power 1 by 3, because this radius is directly proportional to mass to the power 1 by 3, mass number to the power 1 by 3. Yes, A1 is 27, A2 is 125 to the power 1 by 3. So 27 to the power 1 by 3 is nothing but 3, and 125 to the power 1 by 3 is nothing but 5. So ratio is 3:5, which is option B. Well done, well done. Good job everyone. Okay, option B is the correct answer. Chaliye. Next is this one. An AC source of angular frequency omega is fed across a resistor R and capacitor C in series. The current registered is I. Now if the frequency of the source is changed to omega by 3. So resistance is R, XC will be 1 upon omega C. Current is I. Now we are changing the angular frequency of the source to omega by 3. So resistance will be same, but XC dash will be 1 upon omega by 3 into C, which is 3 up times 1 upon omega C. 1 upon omega C is nothing but the old capacitive reactance, so it is 3 times XC over here. Now when you change the angular frequency to omega by 3, the current in the circuit is found to be 1 by 2, right? We are keeping the potential same. Calculate the ratio of reactance to resistance at the original frequency omega. We have to find the ratio of XC divided by R at the original frequency omega. So initial current I is V upon Z, which is under root of R square plus XC square. Now final current is I by 2 at the same potential, and now it will be Z will be under root of R square plus nu XC dash square, which is nothing but 9XC square. You have to write 3XC whole square over here. Fine. Now just divide it. If you divide it, VV cancel, II cancel. So 2 will be under root of R square plus 9XC square divided by under root of R square plus XC square. Square and then cross multiply. So it will be 4 times R square plus XC square, and it should be R square plus 9XC square. So it is 4R square is equal plus 4 XC square is equal to R square plus 9XC square. So from this one we have 3R square is equal to 5XC square. What do we have? XC upon R ratio, na? So XC square divided by R square will be 3 by 5. So XC upon R will be under root of 3 by 5, which is option A. Okay, which is option A. Well done guys, good job everyone. Chaliye, let's try this one. A parallel plate capacitor is charged and charging battery is disconnected. Now if the plates of the capacitor are moved further apart by means of insulating handles, then what will happen? So we are disconnecting the battery, so charge on the capacitor will not change, right? So charge will be same, but since you are increasing the separation between the plates, the capacity epsilon naught A by D will decrease because we are increasing D, so overall capacity will decrease. So what is the energy stored by the capacitor? It is Q square upon 2C. So if capacitor is decreasing, energy stored by the capacitor will increase. So correct answer is option D. Okay, chaliye, well done guys. Try this one. A double convex lens is made up of glass which has refractive index 1.55 for violet rays, and for red it is 1.50. If the focal length for violet rays is 20 centimeter, what is the focal length for red? Okay, so here you have to apply this formula. 1 upon focal length is mu minus 1 into 1 upon R1 minus 1 upon R2. So focal length for violet is 20, mu for violet is 1.55, minus 1 is 0.55 into 1 upon R1 minus 1 upon R2. 1 upon focal length for red is equal to mu minus 1. So mu for red is 1.50, 1.50 minus 1 is 0.5 into 1 upon R1 minus 1 upon R2. Just divide. 1 upon R1 minus 1 upon R2 cancel. So 1 by 20 divided by 1 by F will be F upon 20. And it should be 0.55 divided by 0.5. Remove the points. 0, 0 cancel, this 0 cancel. So over here focal length will be 55 into 2 divided by 5. So it will be 11 into 2, which is 22 centimeter. Option D is the correct answer. Fine. Option D is the correct answer. So that is it for today's session everyone. Thank you so much. We have one more news for you. We are starting Vaidya 2025 batch for you only. So if you want to be a part of this ultimate NEET long-term course, please fill the Google form which is given in the description box over here. Right. So what are the special features of this batch? We'll focus more on physics and chemistry, deep focus on critical chapters. We'll be practicing a lot of questions like 20,000 plus questions, 30 weekend test and 15 grand test will be there for you to practice. Right. So please fill the Google form for further information. This is the ultimate ticket to your dream medical college. Right. So like this video, comment, share and subscribe to the channel, and I'll see you guys on Monday at the same time, and we will be solving few more interesting questions on Monday at 12 to 1. So that is it for today's session everyone. Thank you so much guys. Take care bachcho. Bye bye.